Hello and welcome to a next lesson in topic 3. The title is 3-6, Applying Properties of Operations, Algebraic Expressions. So you've learned before that a numerical expression simply is a number sentence, strictly numbers and operations. An algebraic expression is a number sentence that has variables in it. You should remember that from the last lesson. On your paper, you should have paper for notes. On your paper, please write these 3 words: commutative property, associative property, distributive property. Pause the video if you need more time to write the words. And as you are writing, listen to the definition and listen to the abbreviated definition. So here it says, commutative property is the order doesn't matter when you're solving a problem. You can swap the positions of the numbers when adding and multiplying, and the results stay the same. Under commutative property, instead of writing all this, please write order doesn't matter. And here's an example. 3 plus 5 is 8. 5 plus 3 is 8. It doesn't matter the order. Commutative properties, they commute. It doesn't matter how you travel as long as you get there. The order that you travel. When you're going around campus, you can go different ways to get to the cafeteria. You can go alongside the auditorium, go down, boom, you run into the cafeteria, or you can go near the pit, go straight down, make a right, boom, you're the cafeteria. The order doesn't matter. You're going to get to the same place. Commutative property. Next, associative property. Associative property is, look at the definition, grouping doesn't matter. You can change how numbers are grouped with parentheses when adding or multiplying, and the results remain consistent. Take a look down at the bottom. 2, 3, 4. They grouped 2 and 3, then added 4. You're still going to get what? 9. And same numbers, 2, 3, 4. They group the 3 and the 4. You get 7 plus the 2, 9. So under associative property, just put grouping doesn't matter. So commutative, the order doesn't matter. And again, it only applies to adding and multiplying. For associative, grouping doesn't matter. It only applies to multiplying and adding. Last one, distributive. It says spread it out. You can multiply a number by a sum inside parentheses by multiplying that number by each individual part of the sum, then adding. So take a look at the example. We have 2 outside. Inside the parentheses, it's 3 plus 4. What they did was they distributed, or they shared out, the 2 to both numbers inside. So it's 2 times 3, and then 2 times 4. You're sharing out, or you're distributing the number on the outside by multiplying it by the number inside. So distributive means to share it out, spread it out. All right, let's move on. Take a look at some commutative examples. The order. A plus B, B plus A. You're not going to get a number answer, but if I gave you a value for A and B, you will. 7 plus 9, 9 plus 7, same answer. Multiplication is the same thing. 4 times 6, 6 times 4, you get the same answer. So it does not matter the order, but important. This property does not work with subtraction or division. 5 minus 3 is 2. It's not equal to 3 minus 5, which equals what? -2. So commutative only works with multiplication and addition. Associative, same thing. The grouping, that's what it means. 5 plus 2 plus 8, or 5 and then 2 plus 8. You're still going to get the answer of 15. In this example of multiplication, 3 times 2 is 6, plus the 5 gives you 30. Times the 5, gives you 30. And in the next over here, 2 times 5 is 10, times 3 is 30. Associative, grouping, same answer. And last, distributive. Distributive property is where you group and you're going to share out or distribute. In this example, you'll see that 3 times x plus 3 times 4 gives you 3x plus 12. Another example, 5 times 2 gives you 5 times 2x, and then 5 times 3 gives you 15. The answer is 10x plus 15. We cannot go any further because we don't know the value of x. Look at subtraction version. 4 times x is 4x. 4 times 2 is 8. 4x minus 8, and that's it. So once again, quick review. Commutative means the order does not matter. You switch them with multiplication and addition, you get the same answer. Associative means grouping doesn't matter. When you're adding and multiplying, you're going to get the same answer. And distributive means to share it out. 6 times whatever's in the parentheses gives you 6x plus 12. And we are done. All right. Here's a challenge for those that like it. Let's do distributive on this one. Step 1, distributive. 2 times 3x gives you 6x. 2 times 4 gives you 8. And you bring the 5x down. Now we're going to combine the like terms, meaning the terms that are alike. 6 plus 5 gives you what? 11x. You bring the 8 down, boom, you're done. Nothing else can be done. And let's look at the next one. Distribute. 4 times 2x gives you 8x. 4 times 3 gives you 12. And we bring the x down. When you see 8x plus 1x, even though you don't see that there's 1, you get 9x minus 12. And we're done. Can't do any more. So why are these properties important? Why they matter? It makes math easier. It's a foundation to algebra, which you'll be getting into in high school, and it develops your thinking skills. Takeaway, remember 3 things. Commutative, think what? Order. Associative, think what? Grouping. Who are you associating with? Who are you grouping with? Distributive means you're multiplying across whatever's in the parentheses. Practice makes perfect. Let's hop to your workbook. You should have those pages torn out. Let's take a look at the first example. This is page 187. So it says, Jovan says all 3 expressions are equivalent. So let's find out. Identify and write algebraic expressions. Find the value of each represented expression for n equals 1. So wherever n would be, you're going to plug in 1. So we're doing distributive. 8 is on the outside. N, how much is n again? 1 plus 6. Then you're going to answer what's 1 plus 6. And then your answer would be total of what? Good. So it's 8 times n is 8n plus 6 times 8, and then everything together. Let's do 2 times 4n gives you what? 8n. 2 times 3 gives you 6. So it's 2, but anywhere you see a 1, let's do that. Anywhere you see, an n, plug in 1. Plug in 1 here, plug in 1 here, and there's your answers. Anywhere you see it. Now let's find the value. This is a different problem. -2. So n, put in parentheses -2 plus 6, do distributive, and then solve again. You will only get an answer once you know what n is. Here, 2, 4 times n, it's not 42, it's -2, sorry. 4 times -2 plus 3. So plug in -2 where you see each one of these, do distributive and solve it. Okay? You are going to be working on the remaining pages by reading them. I'm not going to read them for you. This is the same thing I just went over. Just read it. You're going to do try it by plugging in. You're using the 3 and the 9, using distributive for this one. Plug in and get the answer. Again, read up here, look at what they did, and answer, try it. Pause the video when you're ready to move on. Go to the next page. Now we're on page, 189. I need you to read the example. Look at the patterns that you see going on here. And then you're going to try it. Which of the following expressions are equivalent? And explain why. Okay, so look at this, and look at this. The only thing you can do here is pull out a 5, and that leaves you with what in the inside? Here, when you distribute the 5, what are you going to get? Next, substitution. You're going to plug in what they tell you the value is, and then you're going to work and try to solve it. If you don't know the value of n, you're just going to stop where you see things are. So I'm distributing 6 times n. It's 6n. 6 times 3 is what? It's 18. And then you bring the -4 down. So you distributed 6 to everything on the inside. This is where you stop. You have nothing else to solve because you don't know what n is. You're going to do the same thing. Read here. You're going to do the same thing here. Distribute the -2 to everything on the inside, and then combine if you can. All right. Next page. You're going to look at the examples of commutative, associative, and distributive, And you're going to answer questions for, do you understand? I'm not going to read it to you. I need you to read and try to understand it. And then when you get here, page, what is this? 190. For number 6 through 8, use the property of operations to complete the equivalent expressions. So do your distributive, share out 2 to everything on the inside. Here you're going to share out -6 to this and put the answer here. -6 to this, put the answer here. And then bring this over because you're not distributing it, so just bring it here. This one you're going to pull out. They're pulling out 2. So 2 goes into 8 how many times? And then 2 goes into itself how many times? Okay, and then they want you to complete the table. Plug in -1 where you see x, solve it. Plug in -1, solve it. Plug in -1, solve it. And then you're doing the same thing with -2 and -3. Wherever you see an x, plug in the number here, put your answer here. -3, plug it in here, put it here. So you're using -1, -2, and -3 into each one of these problems. And then last problem, from exercise 9, it says which expression in the table are equivalent. So this is exercise 9. Which one of these is equivalent? Have the same answer. All right? Hop to it, and I will be collecting your papers.